The reality of space threats: imagine looking up at the sky, and instead of seeing the usual serene stars, you find yourself pondering the possibility of a gigantic asteroid hurtling toward Earth. It sounds like something out of a Hollywood blockbuster, but according to NASA, this scenario may not be entirely fictional. The space agency has issued warnings about a potential asteroid collision with Earth, sparking debates, fears, and endless speculation. In this video, we're diving deep into the facts, exploring what NASA really knows, examining the controversies surrounding these warnings, and uncovering the truth behind the numbers. Is Earth really in danger? Or is there more to the story than what meets the eye? Let's start with understanding asteroids. What are they? First, let's break down what we're actually talking about when we mention asteroids. Asteroids are rocky remnants from the early formation of our solar system, about 4.6 billion years ago. Most of these objects can be found in the asteroid belt, a region between the orbits of Mars and Jupiter. However, some have trajectories that bring them much closer to Earth. These space rocks vary in size, from tiny pebbles to gigantic bodies hundreds of kilometers in diameter. The largest known asteroid, Ceres, is nearly 1,000 kilometers wide and is classified as a dwarf planet. But even much smaller asteroids can cause significant damage if they collide with Earth. What is the power of an asteroid? Asteroids have collided with Earth before, and their impacts have left behind some of the most significant geological and biological changes in our planet's history. The most famous example is the Chicxulub impact, which occurred around 66 million years ago. This asteroid, estimated to be about 10 kilometers wide, struck the Yucatan Peninsula in present-day Mexico, creating a crater over 150 kilometers in diameter. The impact is widely believed to have triggered a mass extinction event, wiping out about 75% of Earth's species, including the dinosaurs. The energy released by this collision was equivalent to billions of atomic bombs, and the resulting debris cloud blocked sunlight for years, drastically altering the climate. This historical context underscores the potential threat of asteroid impacts. Even though such events are rare, their consequences can be catastrophic. NASA's warning, therefore, isn't just theoretical, it's rooted in the reality of what has happened in the past. NASA plays a critical role in monitoring near-Earth objects, NEOs, which include asteroids and comets that come within 1.3 astronomical units of the Sun. The Near-Earth Object Observations Program, often referred to as SpaceGuard, was established to detect, track, and characterize these objects. The program has catalogued over 25,000 near-Earth asteroids as of 2023. While most of these pose no threat to our planet, NASA keeps a close eye on those that might. The agency uses a variety of telescopes and space-based instruments to track the orbits of these objects and assess their potential for collision. But here's where things get interesting: NASA's detection methods aren't foolproof. While the agency has identified and tracked most of the larger asteroids, smaller objects, those under 140 meters, are much harder to detect. And as history shows, even a relatively small asteroid can cause significant damage. But what did NASA really say? In recent years, NASA has issued warnings about the potential for asteroid impacts, but these warnings have often been misinterpreted by the media and the public. One of the most talked about cases is the asteroid 2009 JF1, which was initially flagged by NASA as having a small chance of impacting Earth on May 6, 2022. NASA estimated the probability of impact at 1 in 3,800, which translates to a 0.026% chance. While this might seem alarming, it's crucial to understand that these numbers indicate a very low likelihood of collision. In fact, NASA later clarified that the asteroid's trajectory had been recalculated, and the chances of an impact were even lower than initially thought. However, the media often sensationalizes these warnings, leading to widespread panic and misinformation. Headlines suggesting that Earth is on the brink of a catastrophic impact sell, but they don't necessarily reflect the nuanced reality of the situation. How accurate are the impact predictions and what is the science behind it? Predicting asteroid impacts involves complex calculations and observations. NASA and other space agencies use various models to estimate the paths of near-Earth objects. These models consider factors like the object's size, shape, speed, and trajectory, as well as gravitational influences from other celestial bodies. However, these predictions are not always perfect. For example, In 2019, a city-killer-sized asteroid named 2019 OK passed just 65,000 kilometers from Earth, about one-fifth the distance to the Moon. It was only detected a few days before its closest approach, highlighting the limitations of our current tracking capabilities. The accuracy of impact predictions depends on several factors, including the size of the asteroid and how far in advance it's detected. Larger asteroids are easier to track and predict, but smaller ones, like 2019 OK, can slip through the cracks, posing a significant risk. Let's talk numbers. As of now, NASA has identified over 1,000 potentially hazardous asteroids, PHAs, with diameters greater than 140 meters. These are the ones that, if they were to collide with Earth, could cause regional or global damage. But what are the actual odds? According to NASA's Planetary Defense Coordination Office, the probability of a major asteroid impact in the next century is low, less than 0.01% for any given year. However, the consequences of such an event would be so severe that even a small probability is worth taking seriously. The Tunguska event of 1908, which flattened over 2,000 square kilometers of forest in Siberia, was caused by an asteroid or comet just 50-60 meters in diameter. This event had the energy equivalent of 10-15 megatons of TNT, about 1,000 times more powerful than the atomic bomb dropped on Hiroshima. These examples show that while the likelihood of an impact is low, the potential damage is high, making it a risk that NASA and other space agencies can't ignore. Now, what can be done? So, what happens if an asteroid is on a collision course with Earth? Fortunately, scientists are exploring several strategies to prevent such a catastrophe. One of the most discussed methods is kinetic impact, which involves sending a spacecraft to collide with the asteroid, altering its trajectory. In 2022, NASA successfully tested this concept with the Double Asteroid Redirection Test (DART) mission. The DART spacecraft collided with the asteroid Dimorphos, a moonlet of the larger asteroid Didymos, and successfully changed its orbit. This mission demonstrated that kinetic impact could be a viable method for deflecting dangerous asteroids. Another potential strategy is the use of nuclear explosions to either destroy the asteroid or alter its course. However, this method is highly controversial due to the risks associated with detonating nuclear weapons in space. Other ideas include using gravity tractors, spacecraft that would fly alongside the asteroid, using the gravitational pull to gradually change its path, or deploying solar cells to harness the sun's energy to push the asteroid off course. While these strategies show promise, they are still in the experimental stages, and more research and development are needed before they can be reliably used in a real-world scenario. The idea of an asteroid collision is undeniably frightening, and it's easy to see why it captures the public's imagination. Movies like Armageddon and Deep Impact have dramatized this scenario, making it a part of our cultural consciousness. But how much of this fear is based on reality? While the possibility of an asteroid impact is real, the likelihood is low, and NASA and other space agencies are actively working to mitigate the threat. However, the sensationalism surrounding asteroid warnings can lead to unnecessary panic and anxiety. For example, in 2012, rumors of an impending asteroid impact linked to the Mayan calendar sparked widespread fear, despite NASA's repeated assurances that no such threat existed. This incident highlights the power of misinformation and the importance of accurate communication from scientific organizations. One of the most controversial aspects of planetary defense is the ethical dilemma of decision-making. If an asteroid were on a collision course with Earth, who would have the authority to decide on a course of action? Should it be a global decision, involving input from all nations, or should the responsibility lie with the country or organization that first detects the threat? Moreover, there are concerns about the potential misuse of asteroid deflection technology. If a country or group were to develop the capability to alter the course of an asteroid, could this technology be weaponized? The prospect of using asteroids as weapons of mass destruction is a chilling one, and it raises serious ethical and geopolitical questions. These are not just hypothetical scenarios, they are real issues that the international community must address as our ability to detect and potentially deflect asteroids improves. What's next in asteroid detection and defense? Looking ahead, the future of asteroid detection and defense is promising, but there are still many challenges to overcome. NASA and other space agencies are working to improve their ability to detect smaller asteroids, which pose a significant risk despite their size. One upcoming mission is NASA's Near-Earth Object Surveillance Mission, NEOSM, set to launch in the late 2020s. This space-based infrared telescope will be dedicated to finding and tracking near-Earth objects, particularly those that are difficult to detect with ground-based telescopes. Additionally, collaborations between international space agencies, like ESA's HERA mission, which will follow up on the DART impact, are crucial for developing a coordinated planetary defense strategy. However, funding and public interest are ongoing challenges. While planetary defense is a critical issue, it often competes with other space exploration priorities for resources. As the potential threat of asteroid impacts becomes more widely understood, it's essential that governments and organizations prioritize the development of detection and deflection technologies. In conclusion, NASA's warnings about potential asteroid collisions are grounded in scientific reality, but they should not be a source of undue fear. While the possibility of an impact exists, the likelihood is low, and scientists are actively working to mitigate the risk. The challenge lies in finding the right balance between raising awareness and causing unnecessary alarm. Accurate communication from scientific organizations, responsible media coverage, and continued investment in asteroid detection and deflection technologies are all crucial in ensuring that we are prepared for whatever space might throw our way. So, next time you look up at the night sky, remember that while the universe is vast and full of potential threats, it's also home to incredible minds working tirelessly to protect our planet. The story of asteroids isn't just about doom and gloom, it's also about human ingenuity, international cooperation, and the ongoing quest to understand and safeguard our place in the cosmos.